Yeah, hello everyone. This is Dr. Ramkrishnan Raju, Professor, Department of Electronics and Communication Engineering, St. Martin Engineering College. Now I am going to give you a presentation on modulation techniques. Now today we know the importance of and the developments in communication. The role of modulation is required because we can't transmit the original data, that is voice data, or it is in the audio signal, it is in the audio frequency range as it easily, because while traveling the original signal it may lose its strength, so it may travel maximum without any modification, without any modulation, it may travel only just a few meters. So our focus is to transmit the data over long distance, hundreds of kilometers. Now the technology is available, mobile communication we are seeing, in which the data is available within, data is transmitting within just a few seconds over the world. So that is the technology, and the fundamentals relating to this modulation is to understand the meaning of modulation. So we agreed that there should be a modification for the original signal, because just now I told as it is without any modification we can't transmit. So that is the modulation. Modulation is a process in which the signal will be varying one or more characters of the periodic waveform, that is a carrier signal. Carrier signal with respect to the instantaneous amplitude of the modulating signal. So here what our assumption is, either modulating signal is in the sense it is a original signal or a message signal or a baseband signal, whatever it may be, and the carrier signal is a RF carrier signal, and both our assumption is sinusoidal signal only. Our discussion is limited to the sinusoidal signals, not the other waveforms, because of the required maximum the transmission, electrical signal transmission we prefer in the sinusoidal signal form. So this is what the modulation, so modulation is required. Then you can know the importance of the modulation, why the modulation is required, where it is applicable, right? So for distance transmission of the data, long distance transmission of the data, we require the modulation. Then if it is in the low frequency range, the noise will be affected very easily. So in that environment also, to control the noise, yes, the modulation is required. So it shows the importance of the modulation. Without modulation, yes, we can't. Then it is about the need for modulation. So why we need modulation in the communication, especially voice data communication or the music communication, the signals are in the audio frequency range. So once the audio frequency range is modulated, yes, it will be done the frequency translation. We are doing modulation means it is a frequency translation. The low frequency audio signal is converting into the high frequency signal. So the frequency transformation is done, that will be called as the frequency translation. So once the frequency translation done, the what will happen in the overall communication is, here it is written just practical size of the antenna. So the focusing is, the main focus of this modulation is reducing the size of the antenna. Now suppose if you take a original signal 20 Hz to 20 kHz, even if you take a higher end 20 kHz signal, it could be overall nearly 3.75 kilometers height antennas are required. Practically it is just impossible, even though it is high end of our original signal frequency. But if you go down, it could be hundreds of the kilometers. So it is practically, it is not possible at all. So that is the reason where we will get the advantage once it is increased. The frequency translation done like 10 megahertz. I have taken example of 10 megahertz, that 3.75 kilometer high antenna size will be reduced to just 7.5 meters high. This is the practical. Nowadays you have seen in the mobile phone, yes, wherever communication is there, there is a antenna. In the mobile phone, it is almost invisible because the modulation or carrier used in the mobile communication is very high frequencies, hundreds of megahertz. So sometimes it could be gigahertz also. That's why invisible antennas. But at least in the normal communication, so we used to focus on few megahertz, so it will be greatly reduced the size of the antenna. This tells the need of the modulation. Without modulation, yes, we can't transmit the data over long distance. Then another one is a power radiation, where the power radiation takes place. When the signal is transmitting over long distance, with the transmitting antenna, the radiated power is another key parameter to be considered. Here, once it is using original signal, the radiated power could be, means the signal traveling with a very low power. It cannot transmit over distance. So, once the frequency translation done, so it will be given radiated power is 1 by lambda whole square. This is just a small expression only, and whereas the antenna height is lambda is c by f. So we can calculate, so what is the radiated power according to the given frequency. So similarly here, what we conclusion is, if we frequency translation takes place, the radiated power will be greatly increased. So that will be transmitted over long distance. So you required minimum number of the transmitting antennas. Otherwise, you have to place many number of the transmitting antennas in the given areas. Then once it is done, modulation done, we'll get a frequency multiplexing is possible. Without modulation, there is no question of multiplexing. So multiplexing, we can transmit simultaneously many signals on a same channel. That will happen when the signal is modulated. That facility will get. And the very important factor is, so I told you in the initially, thus greatly, it is the noise will be controlled while it is modulating. Once it is modulated, high frequency transmission at high frequencies, VHF range, UHF range, the noise interference will be less. And here what I want to say is, the signal to noise ratio will be greatly increased due to the modulation process. So it will be increased or improve the noise immunity, overall noise immunity of the system. These are the major advantages, major things we can achieve by using the modulation. That's why it shows the need for modulation is essential. So need of the frequency translation is essential in the communication. This is the first step in communication. Without modulation, we will conclude that we can't transmit the data for a long distance. Then if you look into it, then it will be a types of modulation techniques. What are the different types of the modulation techniques? Once you agreed, yes, modulation is required, then what are the different modulations? So initially, the modulation will be found. What are the types or what are different types of modulations depends on the waveform we assumed. You take a just sinusoidal waveform and then you know what are the characteristics of the sinusoidal waveform. Parameters involved in the sinusoidal waveform, we clearly know from the fundamentals. There is an x-axis is time, means it is related to the frequency, y-axis is related to the amplitude or voltage, and once frequency is there, phase will be there. Depends on these parameters. Yes, these are the parameters which can able to control the modulation. Depends on that controlling, we have the different modulation techniques. So basically, initially, we have the analog modulation and digital modulation. We know what is the analog data, we know what is the digital data. Analog data is a continuous waveform is analog data, and digital data is in the form of zeros and ones. So that data, how it is to be modulated, what are the different modulation processes. We are going to in detail we are going to discuss it. Here, so there are different modulations. So analog modulations are amplitude modulation. So amplitude is one of the parameter of the waveform, sinusoidal waveform or any waveform. So amplitude modulation is one thing, and second one is the frequency modulation, and third one is the phase modulation. So amplitude, frequency, phase. Then if you come to the digital modulation techniques, we have the resemblance to the amplitude modulation, frequency modulation and phase modulation. We have in the digital form of the data, yes, amplitude shift keying, frequency shift keying, phase shift keying. These are the different techniques. Here we have, if you go in depth, we have the different modulation process that I will explain you in detail each individual modulation technique. Now if we come to the first analog modulation. So in the analog modulation, yes, we have the initially in the analog modulation, we have the amplitude modulation is the first modulation process. It is a process in which amplitude of the carrier varies in accordance to the instantaneous amplitude of the modulating signal by keeping the frequency of the carrier kept constant. Here we are major focus is on carrier, adding of carrier to the low frequency signal, that is we are calling it as modulating signal. In the modulating signal, amplitude is there, frequency is there, but we should not touch the frequency component of the modulating signal. We have to only focus on amplitude of the instantaneous amplitude of the modulating signal. According to that, the parameter here is in the amplitude modulation, only the amplitude of the carrier varies, and accordingly we will find the amplitude modulation process. According to the definition, so we know that amplitude of the AM wave is varying. How it is varying? According to the instantaneous amplitude of the modulating signal, the carrier amplitude is varying. If you substitute all these things, general expressions, we will find the AM wave expression is contents. I am just telling you the content of the resultant AM wave is carrier wave, that is a unmodulated carrier is one part, upper sideband and the lower sideband. Upper sideband, lower sideband. It is upper sideband is omega c plus omega m, and lower sideband is omega c minus omega m. So in and around carrier, these sidebands will be formed. There are three parts of the resulted modulated wave, AM modulated wave. That is, one is a unmodulated carrier, other one is a upper sideband and the lower sideband. This will be named as double sideband with full carrier. This waveform will be named as double sideband with DSB with full carrier. It is one of the AM, amplitude modulated wave. So in which we have carrier plus upper sideband plus lower sideband. This is one form of the amplitude modulated wave. Now, actually there is no information in it. This is just simply a unmodulated carrier. The next step is, our focus is in the AM wave is DSB suppressed carrier. The carrier will be removed once modulation process completed, and the carrier will be removed. Due to this, the major advantage we get is the 66.67% of the power required to transmit this waveform will be saved. Power will be saved. So that is its greatest advantage. Carrier, no information here. So whatever you want to transmit, that will be there available in the sidebands. So we don't require it. It will be removed. We have the different methods of removal. Then third is about the SSB-SC. Only single sideband, either upper sideband or lower sideband, that is enough. Upper sideband or lower sideband is enough. Any one of them. So here the greatest advantage is 94% of the power will be saved. Power required to transmit the waveform, it will be saved. So you see, only 94% will be saved, only 6%, whatever the power required, that will be enough to transmit the SSB, SC. So there, whatever information we want to transmit, that will be available. So this is the process here. And here it will be another one, exclusively it is required in TV transmission. Vestigial sideband, the wastage of the whatever the removed sideband here, that small part of the sideband, not full sideband, the small part of the sideband will be used here, and that will improve the characteristics of the filters used, and mainly it will be used in TVs. And SSB-SC, another major advantage is about the bandwidth. So it will be, the bandwidth will be, here it is, bandwidth is 2 FM, and here both sidebands are there 2 FM, but here it is, the bandwidth will also be saved. Power will be saved, bandwidth will be saved. That is the reason this SSB-SC is the basic concept. It will be used in mobile communications. These two will be used in broadcasting, radio broadcasting. So these are the different amplitude modulated systems we have. Next, we'll see the frequency modulation. Frequency modulation, frequency of the carrier is made proportional to the instantaneous amplitude of the modulating signal by keeping the amplitude of the carrier kept constant. Another concept is frequency modulation, FM wave. So here the focus is on frequency of the carrier by keeping the amplitude of the carrier kept constant. So frequency varies, so directly or indirectly phase also varies. So because of this one, the pattern of this FM wave is, there are different frequencies will be allocated. That is its greatest advantage of the FM wave. Here, whereas in AM, the frequency is constant, but whereas in FM, the frequency is a variable term. Because of this variation, right, this will be used, very effectively used to control the noise. If you see the frequency modulation analysis, it will be greatly used, even though it requires very higher bandwidths, high end of the bandwidths, it will be used among analog modulation. This will be greatly using and very oftenly using the modulation technique, because it has a noise controlling power, noise controlling ability, and it can able to discriminate the noise of the signal to the source noise. So due to this, the quality of the complete modulated signal will be very high end, irrespective of the other disadvantages. Then phase modulation, almost similar, identical, except one parameter, that is its phase sensitivity. Related to the phase sensitivity, it's a modulation index of the phase modulation is directly nothing but the phase deviation, whereas in this will be different in this is the comparison among the amplitude complete analog modulation techniques and what we discussed here, and this is its high noise immunity is the greatest advantage, whereas this is very simple to implement. That is the difference among this analog modulation technique. These are the different digital modulations. Whatever analog modulation we discussed, these are almost very close to the digital analog modulation techniques. Like ASK is there, it is almost resemblance of the amplitude. Here, the amplitude of the carrier is the variable, not according to the instantaneous amplitude. Only two level of the digital signal, either 0 and 1. So, for 0, one amplitude level and 1 is another amplitude level. That is in ASK. In FSK, it will be two different frequencies. For 0, it is one frequency, say F1. For logic 1, it will be another frequency, it is F2. And finally, the very important aspect of the digital modulation focusing on phase shift keying, and it has own advantages. That is the reason we have BPSK, DPSK, QPSK, 8PSK, 16PSK, M-array PSK. So these are all PSKs. The phase shift keying, it is focusing on completely phase related. It is nothing but a BPSK 2 phases and QPSK 4 phases and 8PSK and 8 phases. Similarly, M-array, that's all depends on the number of symbols what we required to transmit. So accordingly, we have the PSK, and we have another system is about the overall comparison of this ASK, FSK, PSK. So here you see the bits per symbol, and here QPSK2 and 8PSK, 16PSK. Similarly, the phases here, and this is the bandwidth efficiency. What is the bandwidth efficiency? Right, bandwidth efficiency and noise immunity moderately it will be used. You see the binary PSK, because I told you it is its greatest advantage of the among the digital modulation techniques. PSK, it is highly preferable. Here you see this is having QPSK higher than BPSK, higher than QPSK. This is the highest. So once we are allocating the phases, number of phases are increasing, and you see the bandwidth efficiency is how it is going to increase. And similarly, the noise immunity will be increased, and it is moderate here, it is good here, more susceptible noise, more susceptible to noise. Noise immunity is also greatly increased if you are increasing the phases like this 2 phase, 4 phase, 8 phase, 16 phase. If you are able to increase it, it will be different. So anyway, the complexity will be there. Once it is simple way, binary, it is the simplest one, but these are little complex because of its generation, its detection, and this will be most complex. Similarly, M-array, if you go to M-array, it will be highly complex one. So irrespective of that, it has its own advantages. These two, I told you, this is an important aspect of the digital modulation, especially about this PSK. Then in addition to this PSK, we have the one more thing, QAM, the quadrature amplitude modulation. It is combination of PSK and AM. The final thing is QAM, quadrature amplitude modulation. So it is just a combination of taking the advantages of both the PSK related, QPSK related, and this is amplitude simplicity and all. We'll take this both together, it will be ASK, and combined it will be your QAM. Right. So this is the overview of the digital modulation. And if you look into it, if you look into the details given in this video, yeah, this is where I told you the importance of the all related to the PS case, and that's all about this topic connected to the modulation techniques. Thank you, Ananda.